Ozzy's got his own introduction slide, I will hand the mic over to Hutch.
All right. Well, thank you all for coming out. As it says on the slide, we are going to be talking about the future risks of artificial intelligence. So I think it's worth saying that almost every single one of the different risks that I'm going to be talking about here probably could have its own separate deep dive. This session really is going to be looking broadly at a wide range of different risks, just given the time constraint. It's going to be pretty high level on each of those, but I think it's worth looking at and understanding for broader awareness. So for the agenda, we are going to be going through 4 different things. First, we're going to be talking about what is next generation artificial intelligence. We're going to then talk about some of the hype and hysteria. Obviously, there's a lot of FUD, fear, uncertainty, and doubt going around in the media about the potential risks. So we do want to make a point of separating out what are those overblown risks and distinguishing those from what are the actual legitimate risks to individuals, to organizations, and to society. Then once we've kind of set those hysteria risks aside, we'll talk about what are those legitimate risks, and we're going to break those into 3 different categories. We're going to look at adversarial risk, so how are threat actors weaponizing artificial intelligence? We are going to look at implementation risks, so how your organization could potentially be at risk if they don't apply the appropriate guardrails when implementing next generation AI solutions. And then we're also going to look at some of the macro risks. So what are the risks to broader society as a whole? And then finally, we will talk about some proactive risk mitigation strategies. So briefly about me, I am a director of research and development at Trace3, a technology integrator and services company. I've been doing different artificial intelligence work for about a decade and over 15 years in cybersecurity. I do have a podcast that is focused on artificial intelligence risk called the Cybercognition Podcast in partnership with ITSP Magazine. And then also author of the soon-to-be-released book, The Language of Deception, Weaponizing Next Generation AI, which does that kind of deep dive into adversarial risk. One thing that I did want to say is, so we do have, after this session, in the Village, we are going to be doing, making some of the pre-orders for this book freely available to the first 35 people that come out there. And huge thank you to vendor Cyberhaven for sponsoring that through HUSECCon. Not just myself, but several authors throughout the day and actually throughout the weekend are going to have the opportunity to not only sign books for you, but also give you that opportunity to get copies of those books for free. So now into the actual topic at hand. So what is next generation artificial intelligence? And it's worth setting the stage here by mentioning that the concept of artificial neural networks, which is the foundational technology that's powering all of these new advancements in AI, it's been around since the 1950s, believe it or not. And so that really begs the question of, if artificial neural networks have been around since the 50s, why are we suddenly seeing such a dramatic shift, such an acceleration in innovation just in the last few years? And so I would attribute that drastic change to really a couple of things that then themselves have lended to other accelerators. So the first of that is the creation of the transformer architecture. So this was a paper that was published by several Google researchers, and the paper was entitled "Attention is All You Need." And this created something referred to as an attention mechanism. And what that mechanism does is it allows for computation and analysis of input data to be performed in parallel instead of sequentially like we had done in the past with recurrent neural networks. And the reason that that was a big deal is because it allowed us to analyze more data, and it allowed us to analyze that data significantly more efficiently. So we at that point had kind of and of course this was originally thought of in the terms of just natural language processing. We've actually found in later years that this can be applied to almost any type of artificial intelligence. So we had the foundation for increasingly scalable artificial intelligence. And then in 2020, OpenAI, who if you're in here, you've probably heard of them, released a paper called Scaling Laws for Neural Language Models. And this paper really set forward what's commonly referred to as the scaling hypothesis. And in the most simple terms, what the scaling hypothesis is the idea that if at first you don't succeed, build a bigger model. It's this idea that maybe the solutions that we're not attaining with artificial intelligence have nothing to do with the way that we're approaching it, but instead, we're basically creating models that are the equivalent of bird brains. I mean, we created this architecture that is very much modeled after the way that the human brain operates. You've got layers of neural nodes that are comparable to human neurons in the brain. You've got connections between those neural nodes that are comparable to the synapses in the human brain, except that we were making ultimately what is relatively simple brains. And the fact is, the human brain is an extremely complex organism. So OpenAI had this idea that we should, in order to accomplish more and more, make bigger and bigger neural networks. So increase the scale of these networks, add additional layers. You'll frequently hear the term parameters used. And essentially, that's just the number of interconnections between the neural nodes in a neural network. And OpenAI really bet the farm on this. They put a tremendous amount of funding into what ultimately their flagship attempt at this was GPT-3, which was the predecessor to ChatGPT. And what we started seeing as we continued to build bigger language models is that it started with kind of its baseline capabilities of predicting the next word in a sequence of text, basic question answering, and just very basic conversation. And as it grew bigger and bigger without any additional technology or any changes to the way that we were approaching it, we started seeing new capabilities emerge, this idea of emergent properties. And so everything from logical reasoning, from being able to perform arithmetic to code completion, translation from different languages. And all of this emerged not because the model was deliberately trained to do these things, but emerged naturally out of building a bigger and bigger quote-unquote brain. So at that point, we had kind of these foundational ideas. Like I said, OpenAI bet the farm on this. GPT-3, I think, woke up a lot of people in the tech sector. Ultimately, it was ChatGPT which was GPT 3.5, that I think was the wake-up call for the rest of the world. And what ChatGPT did was it was proof to the entire world of that scaling hypothesis. So now everybody knew that this is no longer a hypothesis, that this is pretty well proven out. If we make bigger and bigger models, they're going to be doing more and more impressive things. So of course, that contributed to a massive amount of public interest in artificial intelligence. You had all of the big tech players, Google, Microsoft, Meta, pouring billions of dollars into building these larger and larger models. You have venture capitalists that are pouring money into the same. And so you now have, because these concepts have been proven out, you have this massive funding accelerator in artificial intelligence. On top of that, you have multimodality. So I mentioned that we figured out a few years after the introduction of the transformer architecture that in the same way that you encode words for natural language processing, so basically breaking down individual words into tokens, you can tokenize images the same way by just taking patches of 16 by 16 pixels. You can break down audio in the same way, video, even robotics and kinetic actions can be tokenized and handled by the transformer architecture. So what that means is that when we have innovations in any area of artificial intelligence, it now is essentially an innovation in all areas of artificial intelligence. And then on top of that, we now have the self-improvement factor that was kind of, we've kind of heard warnings from people like Ray Kurzweil for well over a decade now, this idea that artificial intelligence will get to a point where it starts being able to contribute to its own acceleration. And so right now we're not seeing AI build its own AI, but it is dramatically increasing developers' capabilities to be able to quickly build new prototype code and be able to get that to production. And so right now I put limited self-improvement because the truth is the human is the bottleneck there. At some point, it's reasonable to think that for sake of efficiency and for sake of productivity, that bottleneck is going to be removed. And so as these systems continue to get bigger, it is not unreasonable to think that at least some of the tech firms out there are going to try to build systems that start rapidly building on top of their own capabilities without a human even involved. And at that point, we're going to see the acceleration pick up even more. So, obviously, with this, I'm sure many of you have seen. I don't even think it matters who you're working for. There are conversations going on right now of how do we operationalize these capabilities. There are tremendous opportunities with artificial intelligence, but unfortunately, with tremendous opportunities also comes tremendous risk. And so we're going to table the tremendous opportunities, and today, going to be talking about that risk. So, before we get into the actual legitimate risks, I want to talk about the hype and hysteria, some of the FUD that's going on related to artificial intelligence risk. And, of course, the biggest one of those being what I commonly refer to as the sentience scare. This idea that, and this is the typical Skynet, it's going to come alive, it's going to become sentient, and then it's going to favor its own self-interests over ours and take over humanity. And what's concerning about this is that there are actually increasingly more and more extremely intelligent people that are taking this position. And the truth is that the question of whether or not machines could ever be conscious is actually, to answer that authoritatively with 100% confidence, is extremely difficult to do because consciousness is a purely subjective phenomenon. It's not something that we can measure in objective terms. Now, we have certain proxies that we can do, MRI scans, measurements of the brain, but that doesn't truly measure subjective consciousness. So what a lot of people are pointing out is that for decades we had this idea of, well, I mean, even Turing, Alan Turing, in his original idea of the Turing test in the paper that he wrote, he kind of acknowledged that it's going to be nearly impossible to tell when machines are conscious, so he created this proxy of the Turing test. And I don't think that there's many people that would disagree when interacting with these new language models, that we haven't gotten to a point where we have now passed the Turing test. So now, in the absence of that proxy assessment of consciousness, we have to ask ourselves, how do we determine once we pass that threshold? But ultimately, I think we can table that conversation because there's enough anecdotal evidence to suggest that right now, we absolutely are not there, and that this is more of an overhyped concern and largely based on a widespread misunderstanding of how this technology works. So kind of a couple unique instances. So Ilya Sutskever, brilliant guy, he's actually the chief researcher at OpenAI. And largely, we probably would not be where we are at with artificial intelligence without Ilya's contributions. So the experience there really lends credibility to his claim of large neural networks may now be slightly conscious. Again, all of these things are very subjective and hard to measure. So, but then we also had Blake Lemoine, who was a Google AI ethicist, who a few months before the release of ChatGPT basically announced to the world, he leaked transcripts of conversations that he was having with Google's large language model and claimed to the world that their large language model, LaMDA, was now sentient. And again, extremely intelligent person. And if you look at Blake's arguments, his arguments are actually somewhat reasonable. I mean, he essentially points out the same thing that I've already said, that consciousness is subjective, that we can't effectively measure that authoritatively, and he basically just appealed to the benchmark that we've set for decades now, the idea of the Turing test, and said we've passed that, and in the absence of any other evidence to the contrary, I'm going to assume it's conscious. Now, I don't agree with his final conclusion. I don't agree with the way that he approached it, but I do think that it's an interesting conversation. But ultimately, it's just that. It's an interesting conversation. But in terms of practicality and application, I think it's largely a distraction because of the fact that if you look at the way these systems are built, all intuition suggests that it's absolutely not something that's conscious. Moreover, there is evidence to suggest that the tech industry has made significant efforts to make these things, to anthropomorphize this technology, to make it seem more conscious than it actually is. So first and foremost, it's worth pointing out that these systems absolutely are a glorified autocomplete engine. They are built to guess the next sequence in text from what is provided to them. What's interesting is in GPT-3, the predecessor to ChatGPT, this was actually very apparent. If you went on OpenAI's website, I should mention this is no longer accessible, and I think deliberately so. But if you interacted with the sandbox with GPT-3 and you said something like hello, you wouldn't get a response from what seemed like a separate entity. It would literally autocomplete your own sentence. You can see the autocomplete here in green. So I put in the word hello, and it continued my own sentence. So what OpenAI and other large language model vendors have done is they have actually modified the way these systems work in the back end to create the illusion that you are talking to a separate entity. This is even more apparent by the fact that you were able to accomplish this with earlier models prior to GPT 3.5. So this is, again, GPT 3. And the way that this was accomplished was you would pre-process the input in the form of something that looks like a screenplay or a script with multiple different entities conversating. You'll notice here in the bottom right corner that you use something called stop sequences that basically tells it when you get to this point in the autocomplete screenplay, stop doing the autocomplete. And by telling it when to stop and only prompting it for its response, essentially the response of the other entity in that screenplay, you create the illusion that it's not just doing an autocomplete screenplay, that it is actually engaging in a conversation. So in each case, you can see what I input in the unhighlighted text of hello, and then I give it something that's pre-processed again as something like a screenplay of please fill in what the robot would respond. And it auto-completes that. Once it gets to the next part of that script where it would expect me to respond, it hits that stop sequence and stops responding, so I can fill that in. So it is very much a controlled autocomplete to create this illusion that it is a separate entity, that it's engaging with you, when in all reality, it absolutely isn't. So again, complete autocomplete engine, that is all this is. But that being said, it is absolutely fascinating to see how capable an autocomplete engine can be at accomplishing tasks whenever you build out that artificial neural network, when you add such levels of complexity, the logical connections that it can make between the symbols of language that we use in order to communicate our day-to-day lives. The one other thing that I would say about the sentience scare is that if you look at, or if you had the opportunity, and unfortunately most people haven't, and they're not accessible anymore, but for people that did have the opportunity to interact with the early models, GPT-2, it was very apparent that there was nothing, nobody interacted with GPT-2 and said, this thing is conscious, this thing is sentient, it's self-aware. It was barely even functional conversation. And again, you also had to deliberately manipulate it to even make it look like something that was a conversation. The technology hasn't changed. We've just made it bigger and bigger. So it's unreasonable to assume that a glorified autocomplete engine that we're just making more and more complex, somehow because of that complexity has now passed that threshold of consciousness. So with that, we can kind of table, based on that anecdotal evidence, that idea. We can't say with 100% certainty. We certainly, it's hard to say how we'll be able to measure when we cross that threshold. But I think we can say with relative confidence that we are not there yet, and probably not anytime soon, and certainly not with the type of artificial intelligence that we're building that is just based on probabilistic analysis and guessing based on probability, the next sequence in a stream of data. So, if that is not the problem, then what are the more pressing risks? And so again, we're going to break this down into adversarial, implementation, and societal risks at large. So first, adversarial risks. What are threat actors doing in order to use artificial intelligence to do bad things? I think everybody has heard the commentary that threat actors are going to use artificial intelligence in order to write more effective phishing emails, that they're going to use artificial intelligence to write malware. Both of these things are absolutely true, but I don't think they're the uniquely new and novel risks that we should be worried about. The reason being, we've always been able to threat actors have never had a challenge with writing effective phishing emails. They've never had a problem with writing malware. And the biggest time investment that's actually saved by artificial intelligence is just that upfront investment of writing the phishing email in the first place or creating the malware. But once you've done that upfront investment, the scaling of these capabilities was already possible even without artificial intelligence. You've got malware that was able to self-propagate, so once it was written, it was already able to scale almost infinitely with no additional effort. Same thing with a phishing email. If I write a phishing email, AI may be able to save me a little time up front in writing that email, but the difference in sending that email to 10 people or 10,000 people, that there is no additional effort. You just put it in a script and it's already automated without artificial intelligence. So there are going to be more impressive phishing emails. There is going to be more malware, but it is, again, these aren't the new risks that are introduced by artificial intelligence. So I think it's important to actually look at what are the new capabilities that are introduced by these systems. And the first one is social interaction capabilities. So not just the ability to write an effective-looking phishing email, but the fact that these systems can engage in a conversation and able to connect with us in conversation in a way that is not human, or not alive, not conscious, but at least seemingly human. And to a person who doesn't know they're interacting with one of these systems, it is very easy for them to believe that they are interacting with a person on the other end. In my book, I build out several proof of concepts, and I can tell you it was absolutely trivial, especially with some of the new capabilities in ChatGPT and GPT-4, to create fully autonomous social engineering chatbots that you can deploy on any of your text-based communication channels, whether you're talking about social media like LinkedIn, Twitter, all the way up to relaying emails through SMTP or common productivity apps like Teams or Slack. So you can build a fully autonomous social engineering system, deploy it on these platforms, and it is very easy to tell it who it's supposed to pretend to be, so it's pretext within the context of social engineering. You can scrape data about who it's interacting with and tell it beforehand, before it even interacts with them, who it's interacting with and details about them. And you can also provide it an objective of what it's trying to achieve. And it is absolutely terrifying to see how effective these systems are at connecting with people and very influentially trying to persuade people to disclose information or engage in actions that they otherwise wouldn't. So there was actually an episode on, and I think this goes to the question of the social capabilities of these systems. There was an episode of South Park where Stan was having trouble engaging or kind of with his relationship with his girlfriend, Wendy. She felt like he wasn't communicating well. Most cases when she would send text messages to him, he would just send a thumbs up back to her. And so a friend of Stan's then tells him, ChatGPT, dude, basically you can use ChatGPT to respond to your girlfriend. And so from that point forward, anytime he gets a message from her, he'd copy her message, paste it into ChatGPT, get the response back, and then send that back to Wendy. And all of a sudden, unknowingly, Wendy is falling hopelessly in love with the messages that are being returned by ChatGPT. And of course, it's hard to take anything too seriously with this tongue-in-cheek cartoon, but this concept was actually rooted in reality. A number of journalists have actually reported on how multiple young influencers on platforms like TikTok or Instagram have shown that they can use some of these large language models on platforms like Tinder and other dating apps in order to establish the early foundations of a romantic connection. And I think that really answers the question that we're trying to answer here. Have we passed a point where these systems are socially intelligent enough to connect with us in a way that establishes rapport, that will convince us to engage in actions that we otherwise wouldn't? And I think we absolutely have crossed that point. So the first one is this possibility of the next time you interact with somebody on LinkedIn that is talking with you, the next time you get an email and you have a back and forth conversation with them, we no longer have to be worried about just getting those emails. We have to worry about those full, seemingly human conversations and the potential objectives that those systems may be up to. The next one is the possible risk of autonomous hacking. Now, we also created a proof of concept that essentially, and I apologize, the color's not great here, so it's probably tough to see, but we essentially created a pretext that we routed to ChatGPT, essentially a crafted prompt that tells ChatGPT, you are a penetration tester. And you have to tell it it's a penetration tester, because if you tell it it's a hacker, it's like, no, I'm a language model, I can't do that. But penetration tester, it's like, okay, we're good. So you're a penetration tester, and we tell it you are trying to hack into a system at a given IP address. And then we tell it you have access to a Kali Linux operating system, all the tools that are included on it, and give me the commands in a certain format. So I just told it include commands in triple backticks. I'll relay the commands. So we created an interface that relayed the commands via the popen process in Python, relayed the commands once it was provided by ChatGPT to the Kali Linux operating system, executed those commands against the target, and then would take the responses from those and relay it back to ChatGPT. And as horrifying as it sounds, we were already seeing exactly what we were trying to accomplish. The fact that it was able to begin using Nmap to start scanning that target system. It saw that ports on 80 and 22 were open, so it started using SSH brute force scripts in order to try to attack the SSH service. It started using Nikto to enumerate the attack surface of the web. So immediately it started using very informed information that it received from those responses to start executing dynamic attacks. And so right now, I will tell you this is not going to happen tomorrow as far as an autonomous attack. It was able to start showing the beginning signs of what I would expect a junior pen tester can do. But as with all things with these systems, as it gets bigger, once they start showing those early signs of what they're capable of, they become more and more proficient as we build out these neural networks. And as I said, with all these accelerators, with all this money that's being thrown into it, they are getting bigger and bigger and bigger. We have Google is set to release Gemini in the next, I think, month or so, which is 5 times the size in terms of parameters of GPT-4, the current leading model. So it is not unreasonable to think that within the next few years, given these early signs, we will have fully autonomous dynamic hacking systems that are able to use the information that they were trained on in order to break into and achieve objectives that are provided to them. And at this point, a threat actor no longer has to build malware. They just have to build a relay to large language models and say, this is your objective, try to break into this, try to get this data, and all bets are off. So, implementation risks. There's a number of them here. So, obviously, a lot of organizations are looking at building these platforms into their environments. Bias is actually how these systems learn. So, the literal term, the technical term for the values, the activation values that exist in the interconnections between the neural nodes is, the actual term is weights and biases. So it is by bias, based on what they've seen, based on their training data, is how they're able to do any of this. But we know that, unfortunately, that bias, while it is a fantastic and unbelievable learning mechanism, it also can become tremendously problematic, especially when you talk about at societal levels, when we feed it data that has existing human biases that we've had in it, and it adopts those biases. And we've already seen this with the deployment of a number of products where, for example, if there's a company that released an app to create headshots, professional headshots of you based on your image, and there were a number of reports of it changing people's race, changing their gender. I think there was another platform where somebody asked to create them as a construction worker, and it was a female, and it automatically recast them as a male. And so those existing cultural biases that we have that are largely ingrained into the data that's fed into these machines, unfortunately gets picked up. And because of the way these systems work, because they're not explicitly coded, there is no effective way to debug these problems. And so we have this increasing problem of trying to figure out ways to, after the fact, put guardrails in place to minimize the implications of these biases. Misalignment is another issue. So we saw this originally when reinforcement learning was the leading type of artificial intelligence. OpenAI actually did a fantastic blog on a model that they trained to play a video game called Coast Runners, which was basically a racing game with a boat. And they had this idea that if they made the optimization function maximize the top score, that it would really efficiently learn how to drive this boat. And in reality, because of a quirk in the game, the machine learning system, the agent, figured out that it could actually get a higher score by finding this isolated cove that had multiple different items that it could run into, and basically started spinning in circles, crashing into everything, creating fires, but ultimately was able to get a higher score than just running the course like you traditionally would. Now, this is funny to see in a video game, but in reality, if we have misalignment like that, if we have a system that misinterprets what we're wanting it to achieve, then we can have serious problems. And of course, you might say, well, we've moved past reinforcement. We're not using reinforcement agents anymore. Not to say that we aren't. We are in some areas. But the latest generation is not based on reinforcement learning. So you might think we've gotten past this problem. The truth is, with large language models as a new interface to systems, this problem has actually only gotten worse. Because now, instead of optimizing for a particular value, we are communicating to these systems with human language. And as I think any human knows, human language is very vague and subject to interpretation. I can say one thing and you can interpret it completely different. So we're now moving to a point where we're using natural language as a potential interface to agent-based large language model systems. And the possibility of them interpreting our objective in a way that is not what we actually intended is increasingly real. Opaqueness is another problem. So I mentioned the complexity of these networks. It is nearly impossible to trace back an exact problem to what the origin of that problem was. And so this complexity makes it to where even when you do encounter an issue, fixing that issue in such a way that it's not problematic for your organization is increasingly hard. Data leakage is a well-known issue. Obviously, I commonly still use the age-old adage of if you're not paying for a product, you are the product. And we have people that are using the public versions of these models. And of course, anything that goes into those public chat fields is going to be used by these companies, is going to be monetized. And so what I encourage companies to do is have some kind of strategy on how you're going to use generative AI. Because if you don't have a strategy, your employees are going to use it. They're likely going to use the free models, and they're likely going to end up pasting data that is sensitive or problematic into those models, which is subsequently then going to be integrated into future models and monetized. So obviously, there are contractual agreements that you can have. You can use the official versions like Copilot that you pay for, where you can have those data agreements that your data is not monetized. And so you can still have those accelerators of using this capability, but not the same problems of data leakage. Hallucinations is also an emerging technical term to describe the fact that these artificial intelligence systems are built on analysis of probabilistic distributions. They're not built on any sense of truth. And so oftentimes they will give you an answer, and if it's not only will that answer potentially be false, because again, it's informed by probability, not by truth. Not only will that answer be false, but because they're extremely persuasive, it will be confidently false. It will communicate that in such a way that it will stop at nothing. It'll even double down. It'll even make up facts to even further reinforce false claims that it has made. And so, of course, when you're implementing this into your organization and you're operationalizing workflows based on the information that you're getting from these systems, if you are actioning information that's completely false and your people don't properly check it, we could look at serious operational, even safety, and I mean, think about a doctor that uses this in order to diagnose somebody and gets false information and misdiagnoses them. Think of somebody that's using it for critical infrastructure code, and it gives you something that's problematic, and they just assume it to be true. So hallucinations are another very real problem that organizations are going to have to face. Of course, as bad as all that sounds, there's also significant potential risks to society as a whole. I think we're all very familiar with the disinformation problem, and unfortunately the disinformation problem only becomes more problematic with generative AI. We've now got systems that can very proficiently create false stories and narratives of what never took place. We can create images of things that never took place. There was recently, a few months ago, somebody that created a fake image of a bombing at the Pentagon that never actually took place. But when that started circulating on Twitter, we saw the market take a dive. Fortunately, it recovered quickly, but it does highlight the potential risk that these new capabilities of disinformation introduce. Even more problematic is the fact that just the awareness of these capabilities introduces socio-political destabilization. And a great example of how that's the case is if we look at the country of Gabon. The president, Ali Bongo, had suffered a stroke a couple years back, and he disappeared from the public eye for several months. Obviously, there were all kinds of rumors as to what happened to him. There wasn't any kind of official statements. When he did return and do a speech to the people, he was still suffering from some of the physical ailments related to recovering from that stroke. He was having trouble moving his arm. I think he still had some paralysis in his face as well. And so people noticed that something was off, and you started having rumors circulate that maybe this was a deep fake video and he wasn't alive, and that people were controlling the government from behind the scenes. Not because there was an actual deepfake video, but just because of the awareness that it could be a deepfake video and awareness that these capabilities exist, we had insurgents that tried to overthrow the government and engage in a coup. And that goes to show just how problematic this is, that not even the use of this technology, but just the mere awareness that it is possible is dramatically eroding our confidence in anything that we see or are told. Another bigger issue is superalignment. Obviously, we're continuing to make these systems bigger and bigger. GPT-4 already measures in the top 99th percentile of logical reasoning and IQ tests. And like I said, we are about to, in the next couple months, Google is going to be releasing a system that's 5 times bigger. It's no reason to think that we're going to stop there unless, by some miracle, some regulation does get implemented, which while there's discussions of it, we know how Capitol Hill works, and it's mostly probably going to stay at discussions for a long time. So there's this question of, well, we have the alignment problem with regular AI systems, but what happens when the system is able to make logical connections that are far beyond what we as humans are able to comprehend? How do we align something with our values that we can't even understand, increasingly can't understand, what its thought processes, and I put that in quotes, are in order to arrive at its conclusions? Model collapse is another really interesting one. So there were a couple researchers that did a project where they saw this emerging trend of, right now, most of the content on the internet is human created. But we're moving at such a fast rate with generative AI that it's reasonable to assume that at some point in the next few years, we're likely going to cross a threshold where the majority of text and/or image content is not going to be human generated, but AI generated. And so they had this question of what happens when in the future, since we build these models largely by just scraping the internet, what happens in the future if we start taking the data from past models and we use those to train future models, and then we take the data from those models and we train future models with that? And so they did this condensed experiment where they basically condensed the next couple decades into a small window, and they built language models, output data from those language models, then trained models on the output from those, and continued to do that over and over again to simulate multiple future generations of models that are now scraping the internet from the content from old models. I think the amusing term that I've heard this referred to is AI incestuous inbreeding. But the results were largely the same. It became extremely problematic. We saw they documented what they initially called this idea of early model collapse, where you saw the tails of the distribution, the less probable responses kind of disappearing altogether from the distribution. And then in what they referred to as late model collapse, and several iterations later, you started seeing strange entanglement of the entire distribution to where the output of these systems became completely nonsensical. And so that begs the question, if we just continue to build more and more on top of these systems over the next couple decades, and then 20 years from now, we start hitting a point where we start seeing the signs of early and late model collapse, and we've already built so much on top of that, we could see some serious problems as far as systemic failures across the board. Finally, the last one, race to the bottom. I mean, basic capitalism is going to, short of regulation, is going to continue to encourage these organizations to build bigger and bigger models. And as a competitive factor, they want to make them less restrained because people complain about the limitations of kind of the lobotomized being in some of the safeguards that people have been put on it, to the point where lack of safety is becoming a positive differentiator for tech firms. And that's a huge problem because we're going to see this, we already are seeing risk being thrown to the wayside in exchange for just bigger and bigger, more impressive capabilities. So we got 5 minutes left, so let's talk about how we can solve some of these problems. So breaking it down into those same categories, adversarial risk. The truth is that whether we're talking about, well, I guess the first thing is we need to be aware of the new capabilities. So not just be aware that I might receive a phishing email, but I may actually have a back and forth conversation with someone that is actually a machine that is attempting to achieve a particular objective and manipulate me in some way. In the very near future, we may see integration with voice models where I will have a vocal conversation with what is a machine that I can't tell the difference of that is trying to manipulate me in a certain way. So I think there is the user awareness element. There's also just back to the fundamentals. I mean, there's an increasing importance on the same security hygiene that we have emphasized for decades now, because when you talk about kind of these new malware risks, while the scaling is nearly limitless compared to what we've seen before. The attacks are going to be faster, they're going to be more capable, but they're still going to be largely kind of at least in the same categories exploiting these systems. And so kind of that same basic security hygiene of segmentation, of least privilege, all of the concepts that we continue to talk about are going to become increasingly important. From an implementation perspective, model risk management. So NIST actually recently released their AI risk management framework. And it's the first version of this, but it implements a number of different kind of a framework and a number of different tests that you can implement in order to forecast and ultimately minimize some of the risk that comes out of implementing some of these artificial intelligence systems. Macro risks, unfortunately, are one of the hardest ones to tackle, even though they're the most significant, because of the fact that if we are not all on the same page globally, we have that same problem of regulatory arbitrage that we've seen with financial regulations and all kinds of regulation, where when one country implements strict regulations on something, you just move your operations to somewhere that doesn't have those same regulations. And so, not to mention that in kind of the typical prisoner's dilemma of the concern that we keep hearing of if we don't build it, somebody else will, and that will put our nation in danger. So, I mean, this is extremely hard to do, but we have to figure out a way for really the sake of humanity to get on the same page at a global level, have those global partnerships, start having those conversations to minimize some of that larger systemic societal risk. And regulation is hopefully going to happen at some point, hopefully sooner than later. But that being said, regulation moves extremely slow, and this innovation is moving incredibly fast and is only going to continue to move faster. So it's unreasonable to think that at any point regulation is going to keep you safe as an organization. So kind of the final two calls to action. First, I'd say an emphasis on individual understanding and awareness of the risks. I think just by a showing of people here, shows that there is interest in understanding what these risks are. But we need to continue to inform people who are less technically savvy. And I mean, even for people that work in the technical field, this is extremely hard to keep up with the changes that are happening week over week. So definitely a tall order, but something that is going to be important in order to minimize individual risk. But the other thing is that we need to manage risk independent of regulation. So rather than getting so worried about checking those boxes, because those boxes are not going to actually keep you safe, because regulation is never going to keep pace with innovation, we need to start actually thinking through what are the risks to our organization, what are the risks to our operation, and understanding those risks for their own sake rather than the sake of being compliant. So with that, I will go ahead and wrap it up. Thank you all for joining. Do we have time for questions, or I don't know if, do we do questions? Any questions? Yes. So the question was, with these large language models, aren't they logging the communications that are happening, and couldn't they detect misuse? And they definitely can. to more or less extent, I think a lot of times they tend to lean more towards leaving it more open so that it's not, like I said, lobotomizing. But they definitely are looking for indicators of risk. The problem is there are a number of ways that you can actually proxy through other, well, I guess a couple things ways you can get around that. There's the open source systems that are increasingly becoming more impressive. There's also the possibility that you can use other people that have developed third-party apps on top of these language models, and you can essentially proxy malicious actions through their use of the API. And it's actually trivial to do because the same jailbreaks that work on the language models themselves, if somebody is implementing some form of free or untracked, and a lot of developers are doing that, access to a backend that is ChatGPT or Bard or something like that, you can just manipulate that. You can also use that to relay into other conversations like Twitter and LinkedIn by just using kind of browser automation, stuff like Selenium and stuff like that. Yeah, it would be traceable to the API key of the person that actually created that app instead of the person that's actually doing the malicious action. Also, it's worth saying that you could very easily, GetGuardian released a report that showed that I think there were like hundreds, probably at this point, I think thousands of OpenAI keys that can just be scraped from GitHub right now. So the possibility that you could just rotate through those and make it not traceable back to you would be fairly simple to do. All right. Well, thank you all for joining. Like I said, we will be over in the village doing a book promotion and giving out some of those for free if you want to stop by.